Hello, good evening students. So today I will discuss about one of the important reaction of alkenes which is called as oxymercuration and demercuration reaction, and we are going to study about the mechanism of this reaction. So this already we have discussed in the previous class about the acid catalyzed hydration of alkenes, which was only limited by the carbocation stability. So here this carbocation rearrangement can occur to form more stable ion, and which is given in the example below. So this is the acid catalyzed hydrolysis of acid catalyzed hydration reaction of alkene, wherein the water molecule is added across the double bond, forming the alcohol, and this is the product after the addition of water to alkenes. And already we have discussed about the mechanism of the preparation of alkenes from the dehydration of alcohols. This reaction, whatever we have seen in the example, it is just the reverse of the that reaction, wherein the water is added across the double bond of alkene to form alcohols. So here this alkene hydration using the oxymercuration and demercuration reaction path reliably produces Markovnikov product without carbocation rearrangement. So this is the scheme of the oxymercuration and demercuration reaction, which is going to produce the Markovnikov product, and which is without the carbocation rearrangement. This is the alkene wherein the water is added across the double bond, forming alcohol, which will be in presence of mercuric acetate and water in presence of the solvent as tetrahydrofuran, and simultaneously followed by the reduction in presence of sodium borohydride. So like this is the main scheme of the reaction, which is given below. So here oxymercuration and demercuration is a two-step pathway which is used to produce alcohols, which proceeds by Markovnikov manner, and which is a stereospecific reaction, and it is sometimes called as anti-addition reaction. The two steps of mercuration and demercuration takes place on the opposite faces of the double bond, creating trans stereochemistry. So the mechanism will follow up one by one, step by step. This mechanism is almost similar to electrophilic addition reaction. Only the major difference here is the formation of mercurium ion bridge, which stabilizes the carbocation intermediate so that it cannot rearrange itself. Since the metals are electropositive, you know that mercury carries a small partial positive charge in the acetate complex, and it is the electrophile which is going to add to the double bonded carbon. So in the first step of the mechanism, the pi electrons from the double bond to mercury, the pi electron form bond to mercury, while the lone pair of electrons which are present on the mercury simultaneously bonds to the other vinyl carbon, and thus creating the mercurium ion bridge. So this mercurium ion forms in conjunction with the loss of acetate ion. And this mercurium ion stabilizes the carbocation so that it is not going to rearrange. In the second step of the mechanism, the water molecule reacts with the more substituted carbon to open the mercurium ion bridge. And the third step is the proton transfer to the solvent water molecule to neutralize the addition product. In the last step, there is a reduction of organomercury intermediate with sodium borohydride, which will be under basic condition. So this is the actual mechanism of mercuration and oxymercuration and demercuration reaction. So here this is a concerted steps which you can show here. So this is the electrophilic addition where mercuric acetate, mercuric diacetate is added across the double bond. You can see here this is the pi electrons from this is transferred here. Instead, the lone pair of electrons from the mercury, they are transferred to form a complex shape mercurium ion with the elimination of one acetate group, okay, leaving one acetate group with the mercury. So this is called as mercurium ion bridge, okay, which is with the carbocation, okay. So what will happen? The pi electrons from the double bond, they are transferred to mercury, and at the same time the lone pair of electrons which are with the mercury, they are transferred to the molecule along with the simultaneous removal of acetate group. So which is left here, this is with the positive charge, okay. This is called as mercurium ion bridge with a positive charge, which we call it as a carbocation. So to this the water molecule reacts at more substituted carbon, you can see here. And what will happen, when water molecule is added, the proton from the adduct which is formed during the second step will be transferred to the solvent water, and here this after this step there is a reduction which is carried out using sodium borohydride in presence of base, which gives the alcohol. The fourth step of mechanism is beyond your level of study, which is not at all given. You have to study only these many steps for the oxymercuration and demercuration reactions. Please try to understand. The arrows are showing the removal and addition of the products, okay. And so when water molecule is added across the positively charged carbocation, the ring, the bridge, mercurium ion bridge gets open, and when after opening, whatever the ion is formed, it is an oxygen ion. You can just see the positive charge on the oxygen. So to get the stability, what will happen? This proton from the adduct will be transferred to solvent water molecule, and Along with this, there is a reduction of this proton transfer. You can show here. There is a reduction of this product using sodium borohydride in presence of alkali or base, which causes demercuration via reduction giving alcohol. So these are the steps which are involved in oxymercuration and demercuration reaction. Now, to conclude the overall oxymercuration and demercuration mechanism follows Markovnikov's regioselectivity with the OH group attached to the more substituted carbon and H attached to the less substituted carbon. This reaction is useful because strong acids are not required. Carbocation rearrangements are avoided because no discrete carbocation intermediate forms. So here you can see there is an what we can say, OH group is attached to more substituted carbon and H is attached to the less substituted carbon. So what we can say here, while the addition of water, this is the OH group which is going to be attached to the more substituted carbon and hydrogen to the less substituted carbon. With the elimination of hydrogen, the demercuration follows using the reducing agent sodium borohydride. So with this, I think I conclude for the mechanism of oxymercuration and demercuration reaction. Thank you.